but it uses inequalities and the letter x. So people freak out. So I could have said, instead of this, from 4 to 9, I could have said 4 to 10. 10 to 16. Which one, where would 10 go? This one, because that's where it's equal to 10. The data point can equal 10. Here, the data point has to be less than 10. Then I could see 6 this way and this way. So this is the way I was taught. Less books have this, more books have this shit, because less students understand algebra nowadays. Tears. But if you like this way better, like me, and you'll see another reason why this way is better in a minute. And I am trying to push you in this way, but you can totally, this is the way the book does it, so if you do it this way, perfect. Nothing wrong with that. It's just that this way's better. You're not going to get bonus points from me, though, if you do it this way. Let's do one more thing with this. There's something that humans created, everything on the earth, but there's something humans created that makes numbers mean more to us relative to the whole amount of numbers. So we call it relative frequency. This is kind of related to, if somebody said there are more inmates in California than any other state, so California is nothing but criminals. Or like California, something wrong with California. What's wrong with that statement? There are more inmates in California. There are. There's also more people, right? So what's a better thing to use besides pure numbers when you're trying to compare things? You'd better use what? Ratios, percentages. That's what relative frequency is. Relative to the total. How much is in each? So that first class has 4 data points out of what? How many data points do we end up with? 15, right? And there are 15 of them. Okay. So 15, 4 divided by 15 is something. I don't know what this shit is. One third of 80, so like 26.666. Yes? So 26.66. I got to show up. That's my one skill is math, so, Go, Jeff. All right. And of course, this would be the same thing. 4 to 15 is 26.7. 3 is easy, because what's 3 out of 15 is 1 out of 5 is 20%. Same thing again here. Are you guys all with me on this? So relative frequency is another name for percentage. And then the last one, 1 out of 15. And that's going to be 6.666, I think. Somebody can check me on that. I might be wrong. Let's see. Yeah, that's right. 1/3 of that. 6 2/3. Yeah. Okay. Cool. I like it. Everybody with me on that? Is that all right? Okay. So real quick, the last thing. We're going to actually construct this histogram. So what did I say about bar graphs that can happen there, but that cannot happen in histograms? Did we have any empty classes? So there better not be any damn what? Gaps, spaces. There better not be. So do you see an immediate problem with this shit? If you say 4, 9, 10, it's going to be empty between, oh shit. So remember, this is your choice. If you choose to do it this way, you have to live with what I'm about to tell you. All right, this is going to sound weird at first, and I don't care, but there's a limit to me, right? Like Jeff stops existing right there. You with me? And you're like, wow, Jeff is neat. You're not the room. I am the room. No. So Jeff stops right here. And then there's a boundary that if you step inside that boundary, I better know you really well, right? You're like, step off it. So there's a boundary that I accept you to be close to me, or the closest you can get to me, and then there's a limit to me. So these are the class limits, and the class boundaries are 0.5 up and down. So like this would be, oh, you guys are like, ooh, I love this. This is awesome. More of this shit. So this would be 3.5 to 9.5. Where would this go? 9.5 to, do you see how now there wouldn't be any gaps? Because that one stops at 9.5, that one starts at 9.5. So if you want to do it the book way, when you go to make the scale, don't be putting no 4 and 9 shit. You got to do this so that the first class ends where the next class begins. Do you see that? I know, that's the right face to make. But oh well. If you don't want to do it this way. Now, see, now if you did it this way, what would I put down there? 4, 10, 16. Oh, beautiful whole numbers. Again, it's your choice. So it could look instead like this, 4, 10, so forth. But let's do it this way. 3.5, 9.5, and then I just keep adding 6. 15.5, 21.5, 27.5, 33.5. Now, if I want to make a relative frequency histogram, and I want the heights to represent the percentages in each. So how high up should I go? Should I go up to 100? Should I go up to 100%? Hell no, because then your picture would be like, it won't show me anything. How high up do I want to go, maybe? 30. Because it's easy to make a scale then. What kind of scale do you want to use then? Don't go by ones. 1, 2, 3, 4. Fives. I love it. 5, 10, 15, 20, 25, 30. Yes. Stay with me now. You know, if you want to go to sleep at night, just watch my lecture. It's okay. Some of you guys are, you make me so sleep. All right. Don't leave these without labels. This label is easy. Anybody know what I'm going to label this? Where did those numbers come from? So I'm probably going to label this real free, right? Relative frequency. And then what are you going to label this? No. Good try. It's got to mean something to the problem. What was the issue with this? There you go. The number of people wearing black on a given day. Okay. If you don't put labels, you lose points. Because then you're not telling me everything I need to know. And now you just draw. Now this is finally, good God, this should be the easy step. That first class is going to be how tall? A little bit above 25, right? The next class is going to be the same height. Next class is going to go up to 20. It's really hard to do this way on the side. Next class also up to 20. And the last class, poor little dude, just above 5. There. Does that look normal? Normally distributed? Does that look like a bell curve? Hell no. What? I'm sorry. Thanks for playing. What should a bell curve do? It should start low, go high, and come back low. So the one I drew earlier, I put a curve over it, but it was like barely normal. This one, that's not normal. I think when it's normal, it looks like the graph is flicking us off, but throwing us the bird. What do you guys call it nowadays? All right. All right, maybe it's gone out of style totally. So what we're going to get into next time is I'm going to have a worksheet for you guys to work on, where you create your own histogram based on data that hopefully you give me in those surveys. And then we'll keep on going in chapter 2. And then, of course, Wednesday we have that quiz.